Today we are going to solve the problem 2.37 in a very simple manner. The problem 2.37 is a particle in the infinite square well, that is equation 2.22, has initial wave function psi of x and 0 is equal to a sine cube uh, pi x over a between the limit 0 to a. Determine the normalization constant a, find the time dependent wave function, and also calculate the expectation value of x as a function of time. What is the expectation value of energy? So these are the things we have to calculate. First, we have to find the normalization constant. By definition, normalization constant, to find the normalization constant, integral between minus infinite to plus infinite modulus psi squared dx is must be equal to 1. Here it is given psi is a, that is modulus a squared, then sine cube pi x over a whole square. So here the sine cube of theta can be written as in the expansion series 3 over 4 sine theta minus 1 over 4 sine 3 theta. So we know that the sine cube theta is equal to 3 by 4 sine theta minus 1 over 4 sine 3 theta. So psi of n is equal to psi n of x, sorry, psi n of x is equal to square root of 2 over a for infinite square well potential sine n by over a x. So this can be written as you bring this to the left hand side, that is uh, this parameter to the left hand side, which will become a square root of a by 2 sine n psi n of x is equal to psi n pi over a x. So the capital psi of x and 0 is equal to a given initial wave function is a multiplied by sine q pi by a. You replace sine q pi by a as 3 over 4 sine pi by a x, because in this case n is equal to 1 theta, and minus 1 over 4 sine uh, here n is 3 pi over a x. Here you can see you replace this uh, sin x, sin pi by ax. What is sin pi by ax? Is equal to square root of a over 2 psi n is 1 psi 1. So this can be written as square root of a over 2 psi 1. Similarly, here this can be written as, except this multiplicative factor, other thing is square root of a over 2. Here it is psi 3. So you take square root of a over 2 outside as a common parameter. Then first term will be 3 by 4 psi 1. Second term will be 1 over 4 psi 3. 1 over 4 psi 3, because we have taken square root of a by 2. Square root of a by 2. So now we will move further. So we got the initial wave function as a multiplied by square root of a over 2, and this terms inside the square bracket. So psi of x and 0 can be written as a linear combination of c1 psi 1 plus c2 psi 2. Now we know from orthonormal property, modulus C1 squared plus modulus C2 squared is equal to 1. Here you take modulus square of this. This is the common parameter. So modulus a squared, this square root will get removed a by 2, and you square this. That is expansion coefficient of psi 1. So If you square 3 over 4, you will get 9 over 16. Similarly, you are taking, remember that you are taking modulo square. So, even if it is minus, it will become plus, plus 1 over 16 because we are squaring it. Now, if you take, if you add the numerator, you will get 10 by 16. Then you have outside the bracket 2, 1 over 2. So this and this will get cancelled. You will get 5 by 16. So that's what I have written. This 2 is cancelled with this numerator. Then this 2 will get cancelled. 9 plus 1, 10, which will become 5 over 16. So modulus a squared, a multiplied by 5 by 16 is equal to 1. So modulus a squared is, if you bring this to the other side, you will get 5a in the numerator over 16. 5a, sorry, 16 over 5a. If you bring this here, you will get 16 in the numerator and 5a in the denominator, which can be written as a is equal to, if you take square root of 16, you will get 4, and square root of 5a is equal to square root of pi a. 5a will become, here 5a will become square root of 5a. This is the normalization constant. We have seen that psi of x0 is equal to a is multiplied by square root of a by 2, then the multiplied by the linear combination of psi 1 psi 2, that is 3 by 4 psi 1 minus 1 over 4 psi 3. Now just now we have found this a is equal to 4 divided by square root of pi a. And so you replace a by 4 divided by square root of 5a. Already there is a square root of a over 2. Now you can cancel this square root of a and this a. So in the numerator you have a, that also get cancelled with 4 here, 4. So you will get in the numerator 1 because both will get cancelled. Then in the denominator, square root of 5 into square root of 2 is equal to square root of 10. So 1 over square root of 10. Here 3 pi 1, sorry, 3 psi 1 minus psi 3. This is the wave function, normalized wave function, which is a linear combination of psi 1 and psi 3. Now, what about the time dependent wave function? This you multiply by the phase factor. For first term, it is a time dependent factor is e power minus I e1 t over h cross, and e power minus I e3 t over h cross, because it's a wave function psi 3, this is psi 1. So is ground state, this is a second excited state. So we got this expression, that is time dependent wave function is equal to 1 over square root 10 multiplied by 3 psi 1 e power minus I e1 t over h cross minus psi 3 e minus I e3 t h cross. So if you take modulus square of this, you will get 1 over 10. Then 9 multiplied by psi 1 square plus 9, sorry, plus psi 3 square minus 3 times the two real part of psi 1 and psi 3. This is R represents the real part. So if you square it, you will get, if you take 2 times the real part of psi 1 and psi 2. Here psi can be written as the sine cos theta minus I sin theta. So we are taking real part of it. That means cosine part of it. So 2 times 3 is equal to 6. Psi1, psi3, cos E3 minus E1 over H cross T. So this is the modulus square of the time dependent wave function. Now what is the expectation value? The expectation value by definition is equal to integral between minus infinite to plus infinite x modulus psi squared tx. This is naturally equal to a by 2. So even though the wave function is a superposition of two energy eigenstate, that is psi1 and psi3, the expectation value remain constant over the time and is located at the center of the well. You know very well. This happens because the initial wave function is symmetric about the midpoint, that is x is equal to a by 2, and the time evolution does not break the symmetry. So you need not do any calculation. You can, based on this physics principle, you can simply write the expectation value of x is equal to a over 2. A few minutes back, we have seen psi of x0 is equal to 1 over square root 10 3 psi 1 minus psi 3. Now, what is the expectation value of energy? That is expectation value of Hamiltonian is modulus C1 squared E1 plus modulus C3 squared E3. So, what is modulus C1 squared? C1 squared is 3 by square root 10. So, this will become 3 squared is 9 and the square root of 10. If you square it, you will get 10. So, E1 multiplied by E1. Since we are taking the modulus square, this minus will go away. So, you will get 1 over square root of 10. If you square it, you will get 1 over 10 E3. So we know the relation E sub n is equal to n squared pi squared h cross squared over 2ma squared. So the first case 9 over 10 E1 n equal to 1 means you will get pi squared h cross squared over 2ma squared. Next, for E3, you will get n is 3, n squared is 9. So I am taking this 9 here, 9 over 10. Then pi squared h cross squared over 2ma squared. So if you simplify this, you can take 9 over 10 as common parameters. Then pi squared over h cross squared, sorry, pi squared h cross squared over 2ma squared plus pi squared h cross squared over 2ma squared will become is 2 times pi squared h cross squared over 2ma squared. So 2 will get cancelled. You will get 9 pi squared h cross squared over 10 ma squared. If this lecture is helpful, like this and subscribe in order to get the updated videos, and also join in my channel for the growth of my channel. Thank you very much for watching my video and supporting me continuously. Thank you very much.